All right, algebra students, welcome back to this Athenian Stranger tutorial video, where today we are going to work through this entire test review. This is the test review handed out on Friday, and this test will be given Wednesday of next week. This test covers all topics in Unit 1, which could be summarized most succinctly as solving single variable equations and simplifying expressions. Now, not all of this test covers those topics. Some of these topics are topics that build up to the skills required to do those more complicated skills, but we'll go through all of them. Now, a note on the format. In between every question, regardless of how simple, I'm going to put this down. Okay, now that serves two purposes. This red Shakespeare DVD case is going to indicate that we're going to change questions, and it really serves a purpose on my end when I go in to make the pinned comment with all the time codes. Then all I've got to do is search for the red title card to begin, okay, the new question. So don't worry about why I'm putting this down. I'm really trying to create a visual cue that we've moved on to a new question, but it might add a little bit to the time. Remember how I want you to take this review. I would like you, if you would, if you have not already, stop this video right now, go back either on the test document itself or a separate sheet of paper and try to do the questions on your own. This is not intended to supplement. This video is not intended to just give you the answers. Remember, I'm not as concerned about you getting a perfect score, and that's fine, you can do that. What I'm more concerned about is that you understand how to do these questions. Because whether it be in my class, whether it be on a standardized exam, or whether it be in a future class, a math class, you will not have a video sitting there to give you all the answers. So it's on you to not abuse the privilege of having a video with all the answers. And remember this, that the way I solve the problems in algebra is entirely subjective. What does subjective mean? Subjective means that I could have chosen to solve those problems a different way. You could choose to solve them a different way. So if you get the right answer and you've shown good algebra to get there, well then that's great. Okay, so my methods are just in many cases one of the many ways to solve problems. And if you have clever ways to solve these problems that I do not show, please take the time to write them out and put them in the comments section so we can all benefit from your knowledge. Okay, so since I've finished up this little preamble, let me put this title card here, and we'll wait a moment and then we'll begin number 1. Okay, number 1. Number 1 says round each to the place indicated. So we're given a number here. First step is to write it down. And that number is 6.01798. And we're asked to round to this digit right here. The location of this digit is the 10,000ths place. So this is the ones place, then there's a decimal, the tenths place, the hundredths place, the thousandths place, the 10,000ths place, and the 100,000ths place. Okay, always a good review to remember how to round. So this problem is interesting because look, what you do when you round a number, you look at the number you're asked to round, and then you look to the right. This number right here is 5 or bigger. It's an 8. So that means I have to round 9 up. Okay, so that means that 9 becomes a 0 to represent 10. And that causes a chain reaction to the left. Because this is a 0 and it represents 10, I must also round the 7 up. So this will become an 8. right? And that's it. All right, so you've rounded these numbers. So you just write in the rest. And it's important to maintain this final digit here, even though it's a 0, because it's a significant digit. Digits that come after the decimal place like this are significant digits. So you have to write this trailing 0. The answer is 6.0180. Okay. Number 2. In number 2, you can see that the problem is set up to cause a series of chain reactions, and we're given the number 9.66999, and we're asked to round the second to the last digit given, which is a 9. So let's look at this using the same analytical framework. You look at the number you're asked to round and you look to the right. Okay, to the right is a 9, so we must round this digit up to 0, and that requires us to round the digit to the left up to 0, okay, which causes us to round the next digit up to a 7. Okay, and the reason we have to round this 6 up to a 7 and we didn't have to round this digit up to a 2 is because this wasn't 5 or greater, right? This was 5 or greater, and that triggers that chain reaction. Okay? Now what? Well, now we just write in the other digits. Okay? So the answer is 9.6700. We see that answer here. Okay, moving on to numbers 3 and 4. I think the next 4 problems all have the same direction, which is to find the greatest common factor, or GCF. Now, how do you do that? Well, the technique that I teach is called prime factoring. So let me just show you how it works. We'll write down the numbers we have to find the greatest common factor of, like this. And then something you need in your mental toolkit is a list of prime factors. Okay, the first several are 2, 3, 5, 7, 11, 13, 17, 19, 23, and 29. And the characteristic that all these have in common, I don't actually have this list memorized, and sometimes I miss one. What I'm trying to do is think of any numbers that can only be divided by themselves and 1. So, and you go through your head, your multiplication tables, you can't think of any 2 numbers that multiply together to get these. And one thing we always need to remember is that 1, the number 1, by rule is not prime. Okay, so the list begins at 2. So as long as you can remember 1 is not prime and 2 is prime, you just move up like that. Okay, so with those prime numbers in mind, let's factor 24. And the technique is fairly specific. We want to think of the smallest prime number that will divide evenly into 24. Or maybe I should say that 24 should divide evenly in 2. And the way you do that is look at the terminating digit here, this 4, and you ask yourself, is this even or odd? If this digit is even and the entire number is bigger than 2, then the first prime number that 24 will divide evenly into is 2. And you just have to think, well, what's 24 divided by 2? And that's 12. And you either know or you consult your list and you say, well, 12 is not prime and 12 is even, so I'll divide 12 by 2 and that leaves 6. Okay, 12 divided by 2 is 6. But 6 is not prime, so we divide 6 by, let's see, it's an even number, so 2 will be the smallest prime factor, and then we write 6 divided by 2 is 3. 3 is prime, so here's the deal. All these are prime around the perimeter here. So we're going to stop. We're done factoring 24. Now let's factor 54. 54 is not prime, and 4 is even, so 2 is the first prime factor. And now we need to divide 54 by 2. All right? 54 divided by 2 is 27. 27 is an odd number, but it's not prime. And its factors include the smallest prime factor that it will divide evenly into is 3. Another way you could have known that is by adding 2 and 7. 2 plus 7 is 9. 9 is a number divisible by 3, therefore 27 is divisible by 3. That rule for threes is something I didn't learn until, I don't know, last year. And I wish somebody had taught it to me earlier because it's a great trick. And it always works. So 27 divided by 3 is 9. And then 9 is not prime. And its two constituent prime factors are 3 and 3. So here we are again, 2, 3, 3, 3, all prime numbers, so we're done. Now 18. 18 is an even number, but 18 is not prime. One thing to know is that aside from 2, there are no even prime numbers because every multiple of 2 is even, and that means that every multiple of 2 is not prime because one of its factors is 2. So just remember that if you see an even number and it's not 2, you can definitely factor it. So 18 is even, 2 is the smallest prime number that 18 will divide evenly into, and 18 divided by 2 is 9, but 9 is not prime, and that can be broken down into 3 times 3. So we have found all of the prime factors, and now we have to find the greatest common factor of each. And the way we do that is by, it really helps to have a different colored pencil to do this. Circle. You're going to play a game of I Spy. If you've ever played that game, you say, well, I spy a 2 in all 3 numbers. So you need to find numbers that are shared in common in all 3 factor sets. Well, let's see, I spy a 2, I circled it. I spy a 3 in each set as well. Okay, I don't spy any other numbers in common, and we're only looking around the edges here at these prime numbers. Right? So what you do now is write out the product of the primes that you circled, which would just be 2 times 3, and that's equal to 6. Okay, so the GCF is 6, the greatest common factor. Okay, so that would give us this answer here. All right, on to number 4. Number 4 is the same exact type of problem. We'll just write these down. 69, 46, and 92. Okay, let's break down 69. Now, you might have an inclination of what to do here, but analyze it, okay? Follow a process. 9 is an odd number, so 2 cannot be a factor of 69, not a prime factor. So it's odd. So think, what is the next prime number, right? Well, they're all odd, right? But the next prime number is 3, so can 69 be divided by 3? Well, 2 ways to look at it. 6 and 9 are both divisible by 3, so this is fairly straightforward. We know the answer is 23, okay? But if you didn't automatically see it, you could add 6 plus 9. 6 plus 9 is 15, and 15 is divisible by 3. Therefore, we know That 69 is divisible by 3. So we put that small prime number right there, and then we divide 69 by 3. 6 goes in, or 3 goes into 6 2 times evenly, and 3 goes into 9 3 times. So 69 divided by 3 must be 23. I'm starting to write 24. 23. Well, here's the good news for this problem. 23 is a prime number, so we stop. Okay, we can't break it down anymore. Now, let's break down 46. Well, 46 is not prime because it's even, and because it's even, the smallest prime factor must be 2. And now we divide 46 by 2, and we get 23. Again, 23 is prime, so we stop. Now we'll factor 92. 92 is even, so the smallest prime number is 2. 92 divided by 2. I want to say it's 46, but let's go ahead and do the division. 92 divided by 2. 2 goes into 9 4 times. 4 times 2 is 8. 9 minus 8 is 1. Bring down the 12. 2 goes into 12 6 times. All right. So the other factor here is 46. Okay, but as you saw right here, 46 is not prime because it's even. And its factors are 2 and 23. So we've prime factored everything. Now play a game of I Spy, right? I spy a 23 in all sets. So I'll circle that, and then I'll look back. Nope, I don't spy any other common factors in all 3 sets of factors. So the GCF is just 23. Okay? Reason I put these questions on this is because this skill is going to come up all year and for the rest of eternity in math. You got to be able to break it down. So I hope that was helpful. Okay, remember we're still doing the same direction from the last 2 problems, which is find the GCF. But now instead of numbers, we have numbers and letters together. Luckily, this doesn't complicate the situation at all, just marginally. So let's go through this. In the way we want to do it is in 2 steps. Step 1 is to factor the numbers in front of the letters, and when numbers are in front of letters, we call those numbers coefficients. And so the rule is factor the coefficients, then factor the variables. Okay, so we're going to end up making 3 trees. We'll start with 9. 9 is not prime, and its factors are 3 and 3. 21 is not prime, and 2 plus 1 is 3, and 3 is divisible by 3, so 21 can be divided by 3. 21 divided by 3 is 7. Okay, 3 and 7 are both prime. 30. 30 is even number, so it's not prime, divisible by 2. 30 divided by 2 is 15, but 15 is not prime because it can be broken down into factors 3 and 5. Now we have all prime numbers. So let's find the numbers in common. I'll circle I spy a 3 in all 3 sets. And that's the only factor in common. So this part of the GCF, we'll just write as like a little placeholder, is 3. Now we got to factor the letters. A squared, a to the 4th, and a to the 4th. Okay, now this looks a little bit weird, right? But you got to remember your product rule. which says that when you multiply letters together, you add their exponents. And remember, a letter all by itself has an exponent of 1. And so that means that a squared is really just a times a. And there it is, you factored a squared. A to the fourth is just a times a times a times a 4 times, like that. And a to the fourth again, a times a times a times a. And so we're going to go play the game again, I spy. Okay, I spy an a in all 3 sets, and I spy another a in all 3 sets. So to get this part of the GCF, you just multiply a times a, which gives you a squared. So now what do? Well, you multiply this portion of the greatest common factor by this numerical portion of the greatest common factor. So 3 times a squared will give me the GCF, and that is equal to 3a squared. So 3a squared is the GCF. Another hugely important skill to be able to do. All right, on to number 6. Number 6, we are given all this nonsense. The coefficients are 45, 36, and 36. Okay, luckily we're only going to have to do this twice because this one will be identical to this one. So now 45, 4 plus 5 is 9, 9 is divisible by 3, therefore 45 is divisible by 3. And 3 times 15 is 45. 15 is not prime, and 15 is 3 times 5. For reasons that will become more clear later in the year, we always want to start with the smallest prime factor on the left side. So we wouldn't want to put 5 times 3. We want to kind of keep the 3's lined up together. So just do it the way I've done it, and it'll become clear later in the year. All right, 36. 3 plus 6 is 9. 9 is divisible by 3. Therefore, 36 must be divisible by 3. And indeed, 3 times 12 is 36. All right, now let's break down 12. All right, 1 plus 2 is 3. 3 is 12. 3 is divisible by 3. Therefore, 12 is divisible by 3. And 3 times 4 is 12. 4 is not prime, and that's 2 times 2. All right. Now we just do 36 again. 3 and 12. 3 and 4. 2 and 2. Okay. And just on a quick note, these numbers could have been factored with the 2's first. And honestly, if I was keeping to my system, I would have done that. It doesn't really matter as long as you've got them grouped together, but would have been a better idea to say 2 times 18 and then broken it down like that. So if that's how you did it, congratulations, you did it more correctly than I did. Now let's play I spy. So I spy a 3. And I spy another 3. All right, and those are the only 2. So the numerical portion or the coefficient portion of the greatest common factor would just be 3 times 3, and that would be 9. So now let's work on these letters. Here's our sets that we're given. U squared times V, U, and U cubed, U to the 3rd power. Okay, so let's break these down. U squared is just U times U, and V just comes multiplied along for the ride. Okay, so U squared V is U times V. Well, U is just U. and u cubed is just u times u times u. So we'll just play a game of I Spy. I spy u in all three sets, and that's the only one I find in all three sets. So the variable portion of the greatest common factor is u, and now we'll multiply that back with the numerical portion, and we get 9 times u equals 9u as the GCF of all three, 9u. Okay, on to number 7. And number 7, the LCM, the least common multiple. This is actually, it's actually something you need to pay close attention to, because these problems are on the one hand, they're simple, and on the other hand, you need to think about it a little bit. So we have 40, okay? We have y, let's write it like this, and we have 24. Now, let's prime factor 40 and 24, and then I'll show you what to do next. So 40 is even, so that would be 2 times 20. And then 20 is even, so that would be 2 times 10. And 10 is even, and that would be 2 times 5. Okay, y is just y. 24. 24 is even, that would be 2 times 12. 12 is even, that would be 2 times 6. 6 is even, that would be 2 times 3. All right, so we factor down to primes. Now, here's what I'd like you to do. Make a little table here. Write down 40, y, and 24. Put colons right here. If you don't do it this way, you might mess up. So let's just write out the prime factors of 40. 2 times 2 times 2 times 5. Now the factors of y are just y. And 24, that's 2 times 2 times 2 times 3. All right, now we have to make another little table. We're going to write down all the factors that we see, okay, just the factor part. 2, 5, y, and 3. Make little colons here. And now we're going to perform a little analysis. What is the greatest number of times I see a 2? All right, so here I see it 3 times, and here I see it 3 times. There's no other 2s, so the most it occurs is 3 times. All right, stay with me on this. How many times do I see a 5? What's the most number of times? Well, the most number of times I see a 5 is once, 1 time. If you write the table like this, you'll never go wrong. Y, I see 1 time. 3, I see 1 time. So this is the greatest number of times I see these numbers. And now watch what you do here. You say, well, I see 2 3 times. So 2 times 3 equals 6. 5, I see 1 time. 5 times 1 is 5. Okay, I'm going to put the y at the end. So I see 3 1 time. So 3 times 1 is 3. And now y, I see 1 time. So y times 1 equals y. Now when you got here, you're good, because what you're going to do now is multiply all these together. So let's try to do that in our head. 6 times 5 is 30. 30 times 3 is 90. Okay, so, wait a minute. Wait a minute. 2 times 20, okay, 2 times 10, 2 times 5. Yeah. And then this would be 2 times 2 times 2. All right, well, why am I not getting what I want here? So, hang on one second. This is 30 times 3. No, because that's 90. That's not the answer. Oh, okay. I know what I did wrong. Okay, so I made a mistake. And this is illustrative. All right, this is illustrative. Let me go back here and erase this. Now, I'm sorry for doing this live on camera, but guys, this happens. Okay, so might actually try to edit this whole thing out. Let me start this over. I don't want, I now realize I've already confused people by making a mistake, but it does happen. Go back here and just get rid of all this. I made one tiny error and screwed up everything. Okay. All right, so we see that 2 occurs 3 times, 5 occurs 1 time, y occurs 1 time, and 3 occurs 1 time. So over here, we'll write down 2, and we'll multiply 2 together the total number of times it appears, the maximum number of times it appears. So that would be 2 times 2 times 2. Okay, because it occurs 3 times. Here we got 5, it occurs 1 time. So we just have 5. And I want to do the 3 first, then the y. I'll just reorder this a little bit. 3 occurs 1 time. I got 3. And then y occurs 1 time. We have y. Okay, so let's multiply all this out. 2 times 2 is 4. 4 times 2 is 8. Right, 5 is equal to 5. 3 is equal to 3. Y is equal to y. Okay, and now what you want to do is just multiply all this together. Okay, multiply all this together. So 8 times 5 is 40, and 40 times 3 is 120. 120 times y is 120y. So the LCM of 40y and 24 equals 120y. Okay? All right, so it turns out LCM is not as simple as it looked initially, right? LCM, when we learned it in 3rd, 4th grade, whatever, it's one that we need to pay real close attention to. It's harder than greatest common factor, right? It's a more involved process. Okay. Number 8. And number 8, we're given 18 y squared. I'll tell you what I'm going to do. 18 y squared, 12, and y squared. All right. So let's break down 18 into prime factors. And 18 is 2 times 9. And 9 is 3 times 3. Y squared is y times y. 12 is 2 times 6. And that's 3 times 2, or 2 times 3 we should write, 2 times 3. And then again, y squared is y and y. So here's the process. All right. First, we're going to write out our numbers, 18 and 12. And then I'll put y squared down here and y squared down here. Those are going to be identical. Put colons and just write out the product of the primes for each number or letter. So 18 is 2 times 3 times 3. 12 is 2 times 2 times 3. Y is y times y, and then, or y squared. And y squared again is y times y. All right? Now you can actually rewrite these in a way, so I want to make it one step more involved. So you've got the pure method in front of you. 2 times 3 times 3 could be rewritten as 2 times 3 squared. Okay, just make sure you understand that. 3 times 3 can be written as 3 squared because you would add the exponents. Similarly, 2 times 2 times 3 could be rewritten as 2 squared times 3. All right? And y times y could be rewritten as y squared. We just broke that down, and we'll put it back together again. And then this is y squared. And so now we're going to multiply numbers together that have the greatest exponents. All right, so in this case, we'll multiply together 3 squared times 2 squared times y squared. Okay? And that is the same method that we did over here, but it is more succinct. You see there's less writing. So these are two methods that should achieve the same outcome. And let's see if they do. So 3 squared is 9, and 2 squared is 4. So we should be able, times y squared, we should be able to multiply 9 times 4 times y squared and get the least common multiple, which in this case would be 36y squared. So this topic of least common multiples, something I probably should have covered more in class, and so I might cover that more in class just so we can master this. Now these are two identical methods, but done differently. Okay, done differently. As long as they work, you can do it whichever way you feel most comfortable. right? Okay, number 9. Number 9, we're asked to evaluate each expression. Well, this is just this is just going back to adding and subtracting fractions and whole numbers. We're going to be finding common denominators and adding or subtracting as needed. So we can rewrite this and clean this up a little bit. Let's take a look. We got negative 5/3 minus negative 1/3 plus negative 1. Now right here I spy a double minus, and whenever we see a double minus, we see that this double minus right here, we know that that's going to become a plus. All right, so we'll just make that change. And then here I've got the epic battle between plus and minus, and when we see that, minus wins. So we're going to rewrite this as negative 5/3 plus 1/3 minus, now be careful how we write the 1, right? See, 1 could be equal to 1/1. Okay? So we could write this as 1/1. And that would save us one rewrite, one full rewrite. Okay, so I hope this is clear. I just changed the 1 into 1/1. It's still 1. Okay. And when you're doing fractions, you want to do that to save yourself a step of doing that conversion. Now we have to find the GCF of 3, 3, and 1. Okay, so here we go. Or rather, I said GCF, I meant LCM. We need to find the LCM of 3, 3, and 1. Right, so we need the LCM real quick here. So 3 is just equal to 3. 3 is just equal to 3. And 1 is just equal to 1. Okay, so the greatest number of times I see a 3 is 1 time. Okay, so I'll put a 3 here times I see a 1 one time. And so the LCM is 3. 3. All right. Why did we do that? Well, we did that because we're now going to multiply our denominator of 1 by the LCM. All right, but we can't multiply by 3 in the denominator. That's not allowed because it would put the equation out of balance. We have to multiply by 3/3. Right, because you can only multiply in these expressions and equations, you can only ever multiply a fraction by 1. And 3/3 equals 1. Right, so that's okay, right? It's okay. So we multiply by 3/3. So we'll do a rewrite here. Negative 5/3. Okay, we don't need to do anything to that. Plus 1/3. And now we'll multiply across the top here. We'll put a minus sign. Multiply across the top. 1 times 3 is 3. And across the bottom, 1 times 3 is 3. And now we have a common denominator. You see? That was the purpose. Find a common denominator. Now what? Well, let's combine everything into one fraction with 3 in the denominator. So in this case, I've got common denominator. I can just write everything over 3, and then I just put my numerators together. Negative 5 plus 1 minus 3. Okay? And now we'll just solve from left to right, or simplify from left to right. Negative 5 plus 1 is negative 4. Negative 4 minus 3 is negative 7. So we've got now negative 7 over 3. Okay, and that is the expression. Number 10. All right, just another problem like the one we just did. And we will rewrite this. We've got negative 1/4, negative 1 over 4, plus 3 over 2. And now we've got the situation again where we have 2 minus signs, and that would just become a plus. Plus 1 over 2. Okay, now what? Well, we need to find the LCM of 4, 2, and 2. Okay, which really means we need to find the LCM of 4 and 2. So 4 is just 2 times 2, and 2 is just 2. And so the greatest number of times 2 appears in any factor is twice, so that would be 2 squared. So the LCM is 2 squared, or 4. The LCM is 4. All right, so what I need to do is multiply 2 by whatever I would need to multiply it by to make 2 turn into a 4. And I turn 2 into a 4 by multiplying by 2. Here I want to use a different color. Okay, I'm going to use red, but my red pencil is been used too much. To sharpen it. This has nothing to do with, well, I guess it's nothing to do with math class, but this little sharpener here I've had for, I don't know, something like 30 years. I got it when I was a little kid, and this might not be the exact one, but I have one like this that I've had since I was a child, and my dad gave it to me. And this little piece of metal right here, or aluminum or whatever it is, this will last you forever, and I keep it in my pocket at all times. So that might be something you might want to put on your birthday list, Christmas list. It costs like $1, $2, and keep it in your pocket. It'll always help you out. And you can even replace the razor blade if you ever need to, but I never have. Okay, so over here I'm going to multiply 3 over 2 by 2 over 2. And then I'll multiply 1 over 2 by 2 over 2. And now let's see what we get, right? These become little multiplication problems right here. So I'll rewrite negative 1/4 plus 3 times 2 is 6, 2 times 2 is 4, so plus 6 over 4 plus 1 times 2 is 2, 2 times 2 is 4, 2 over 4. Okay, so now we can do one more rewrite here before we get it all simplified. Everything over 4, common denominator has been found. And we write negative 1 plus 6 plus 2. And we solve from left to right. Negative 1 plus 6 is 5. 5 plus 2 is 7. So the simplified expression is 7 over 4. Right? Y'all take a little mental break here. I'm going to grab another cup of coffee. Be right back. Okay, welcome back. I hope you had a little break there. I got coffee, which is perhaps the most essential ingredient for any teacher and maybe any math student. So this wonderful cup of coffee is going to help us propel through the next set of 10 problems. I think because we have 50 problems here to solve or work, we got to do it in pieces. You know, this isn't a marathon, or it is a marathon. You want to pace yourself. And as we're getting back into this here, I want to say I'm proud of everybody, okay, who's watching this video and who's working these problems here. I know it's not easy, guys, and it's something we have to fight through. But the best I can do as a teacher is fight through it with you together, and that's why I'm recording this video. I want you to know that one of my rules as a teacher, it's not a rule for you. There's a second part that's a rule for you, but I will never ask you to do anything that I will not do myself. So at the very least, I want you to know that as long as this video goes, I will be here to do these problems, and I want to support you throughout the year. Your job, your side of that responsibility is that you do what I do. You do the work with me. Okay? That's all that I ask. That if I'm going to put in the time, you put in the time too. All right? So if I was a coach, you know, in a lot of ways I feel like a math coach. Then I feel like if I was a math coach and if I was a coach and I was teaching cross country, that I would run right along with you. If I was a coach and I was teaching baseball, that I would throw the ball and hit the ball with the bat right along with you. And, you know, if I was a swimming coach, I'd swim right along with you. And that way you don't feel like I'm just dictating that you do a bunch of work while I sit by and write grades. You know, we're in this together. All right, so we're a team. This is the math team. This is the Westwood math team. We're in this together, guys. Okay, so let's go Panthers with number 11. Okay, the new requirement here is that we find each quotient. Okay, so this is going to be the keep, flip, change thing, but we have to do it carefully because these are stacked fractions, and these can always be scary. Even as a math teacher, when I see a stacked fraction, I've got to stop and think for a minute. What am I supposed to do? So let's get into this. We're given 2 over 3, 2/3, and we're going to divide 2/3. And here's the key. Write it out like this by -2. And just over inside, we're going to write -2 is equal to -2 over 1. That's going to help you here. So divide 2/3 by 2 over 1. -2 over 1. Okay, so for my people that do keep, flip, change, you're going to keep the first fraction, flip the second fraction, and change the division sign to a multiplication sign. Keep, flip, change. The way I learned it is called invert and multiply, or multiply by the reciprocal. It's all the same thing, and that means that we'll just rewrite this as 2/3 times -1 over 2. Okay, let's just make sure we understand that. And now we will just multiply across the top and multiply across the bottom. When we're multiplying fractions, you do work with the denominator. You multiply it. When we're adding or subtracting fractions, you don't add or subtract the denominators. Okay? So 2 times -1 is -2. And 3 times 2 is 6. So we have -2 over 6. And now we could find the greatest common factor of 2 and 6. Okay, 2 is just 2 times 1, and 6 is 3 times 2. So I can divide a 2. The 2 is the common factor. The GCF is 2. And I realize that this is a bit pedantic. This is a bit long-winded for a simple problem like this. But I want you to get in your head, that's what you're doing. You're going to divide both the top and the bottom by the GCF of 2. So that is equal to negative 2 divided by 2 is negative 1. And 6 divided by 2 is 3. So the reduced fraction is negative 1/3. On to number 12. Number 12 is just the same thing again. And honestly, when I see the double stack fractions, it's a bit easier for me to understand what to do because I don't have to do this little step here of converting a whole number into a fraction. So let's write what they give us, negative 3 halves divided by negative 8 fifths. So keep, flip, change, invert and multiply by the reciprocal. We're going to keep the first fraction, flip the second fraction, and change the division symbol to multiplication. So this is equal to negative 3/2 times negative 5/8. So now we'll multiply across the top and multiply across the bottom. Negative 3 times negative 5 is 15. 2 times 8 is 16. All right, so this is irreducible. If you try to find the GCF of 15 and 16, watch what happens. So 15 is 3 times 5, and 16 is 2 times 8, which is just 2 times 2 times 2 times 2. Well, there's no common factors, so it's irreducible, and so that's it. Okay, let's move on to the next problem. We're moving on to problem number 13. Simplify each expression. Okay, what does that mean? Well, it means just make it simpler. Combine like terms. Okay, we're going to combine like terms here, and we'll dispatch this one fairly quickly. 2x plus 1 plus 10. I can add the whole numbers together, and so this would just be 2x plus 11, right? Number 14. Okay, number 14, we're given 1 plus 6a plus 8a plus 2. Okay, again, we're going to combine like terms, but this time we have two different types of terms that are like. Here, these numbers can go together, positive 1 and positive 2. That can come together, and then we have positive 6a and positive 8a. So we'll combine like terms. And remember, we want to put the numbers and letters up front and then the numbers by themselves at the end, just for stylistic reasons. That's not actually how these answers are listed, but it's the way that should be done. So let's see here. 6a plus 8a is 14a. Okay, plus 1 plus 2 is 3. 14a plus 3. So let's go hunting for something like that in the answer choices. And I see it right here, 3 plus 14a. That's identical to 14a plus 3. The reason I write it like this is because as we move forward in mathematics, the ordering becomes somewhat important. Right now it's not so crucial, but it will be. Okay, number 15. Here's our old friend, distributive property showing back up. But y'all are OGs at this. And just as a preemptory step, a prefatory step, I'm going to write in my distribution lines, okay, just to lay out the trail map of where I'm going, just so I know what exactly I'm doing. It's like a problem-solving method. Okay, so 4 times 6n, that's going to be 24n, plus 4 times 9, and that's 36. And now be careful here. It doesn't really matter, but you could save yourself some time. Look at what you're about to do. Before you write that plus sign, think 7 times negative 4 is going to be negative 28. So if you write plus negative 28, then you have a potential for confusion. Just go ahead and drop that plus sign, because in the epic battle between plus and minus, minus wins. And write minus 28. And now we have, again, think about it, 7 times negative 2n. And that would just be minus 14n. Okay, so if you've written this problem down right and you've set it up correctly, now you just, I highly recommend, maybe I'll get a bunch of them for y'all. Get a double-sided pencil like this. So if you are armed with a straight edge, a double-sided pencil like this, and a pen or maybe a regular pencil, you're set. You can do a lot with these little implements. Okay, so y'all remind me, order double-sided pencils. Or you could just use map colors if you like other colors, any colored pencils. It helps me visually to kind of keep my mind situated. So now let's circle the like terms. So I'll circle 24n, and that is like with negative 14n. Remember to capture that operator right there. And now I've got 36 and negative 28 that I'll combine. That's the reason I like this little pencil, because what I do is I'll flip it in my hands, and I don't have to put a pencil down or anything. Just flip it. So I think that might be good for class. Okay, so now we're going to group those terms together. I just want to make it clear what we're doing. We're going to do 24n minus 14n. Right, and that is a little math problem to do. And you can group that together so you know what you're doing with the little parentheses. And now I have plus another little math problem, 36 minus 28. I'm just grouping the terms together. So now what is 24n minus 14n? Well, in side work, we could do that stacked 24n minus 14n. The n comes along for the ride. And let's see, 4 minus 4 is 0. And 2 minus 1 is 10. So that's positive 10n. So down here, I'll just write equal. Let me make sure this is equal, 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 equal. So then I'll write 10n here. And now I've got to deal with 36 minus 28, more side work. 36 minus 28. Okay, I can't take 8 from 6. I've got to borrow. So 16 minus 8 is 8. And 2 minus 2 is 0. And that's it. It's just 8. So we'll put plus 8. All right, so that's the simplified expression. 10n plus 8. Okay, on to number 16. Here we go. We are given another distributive type problem. And the first thing to do is grab some colored pencils or whatever and show those distribution lines so you kind of know what you're about to do. And now let's do it. So first we'll distribute the b. b times 1 is b. b times 3b. Here, be careful. Maybe we should do it over here. b times 3b. Okay, so remember this is in front of the b, there's a 1. So you're going to multiply 1 times 3. And then remember these b's have exponents of 1. So we're going to apply the product rule here. So 1b times 3b is 3b to the 1 plus 1, which is 2. 3b squared. All right? So b plus 3b squared. Cool. Now we have negative 5 times b, and that would just be minus 5b. And we have negative 5 times negative 1. Negative times a negative is a positive, so 5 times 1 is 5 plus 5. Okay, just be clear, that's not a 6, that's a b. We'll now combine like terms. So here I've got a b, and here I've got a negative 5b. Those go together. And then there's no other like terms. So let's group the like terms together. b minus 5b plus 3b squared plus 5. So b minus 5b, remember that's 1b minus 5b, so that would be negative 4b. Negative 4b plus 3b squared plus 5. And I don't know how this problem is going to show it, but I want it shown in math. In the future, we'll want it shown with what we call the greatest degree or the greatest exponent up front. So the real way to write this would be 3b squared minus 4b plus 5. And I mean, this is not required at all by the problem, but I do want to show what this looks like. All right, this looks like something. This is something we're about to get into, which would be actually graphing these equations. And so I'll pull out the calculator here, and I want to show this graphed. Actually, I'll graph this one as well. So what does this look like? 10x plus 8. Just for fun. This is just for fun. Let's graph it. 10x plus 8. Looks like that. It's a straight line. Okay, that's called a linear equation or linear function. And now let's look at this one. This is looking way ahead. This is called a quadratic, but again, it doesn't matter. We're just taking a look at it right now. All right, so I just typed it in and I replaced all the letters with x's since that's the only letter you can put on the calculator. Let's see what that looks like. Okay, it's real. I've zoomed out a long way, so let me zoom in. Kind of want you to see this. We'll zoom in until it's really like clear in the screen. I'll point a couple things out to you and then we'll move on. I'm just getting you a little bit of a visual for what you're doing. Like a lot of people ask the good question, why are we doing this again? Here's why. So zoom in one more time. We'll get a good fix on this now. Here we go. Okay, so that's it. It's like a curve, right? And one interesting thing to note is that this curve never crosses the x-axis. And another thing to note is that it crosses the y-axis at 5. And that comes, you can actually read that right off the problem. Where the function crosses the y-axis is called the y-intercept. So this has a y-intercept of 5. Right? You could have also looked at your tables and seen that where x is 0, y is 5. That the problem obviously doesn't call for that. I just wanted to show you kind of what's going on coming up. A little preview, a little trailer, okay, for the movie coming up. But now let's go ahead and find this. This problem doesn't order it like I want, but that's fine because we just need to locate these terms. 3b squared, there it is. Negative 4b, there it is. Plus 5, there it is. Okay. Didn't mean to spend so much time on that, but I wanted you to see what it looks like because there's more to it than what we're doing. But we'll get there. All right, number 17. Uh-oh, this looks scary. It isn't. It isn't scary at all. There are multiple ways to solve a problem like this or work a problem like this. I want to show you one way, okay? All you have to do is stack add. I like to stack add with these because it makes it clearer. If you write it all out without the parentheses and you try to combine like terms, it just becomes a little bit tedious and there's a lot of potential for mistakes. So here's how I'm going to write this. I'm going to look for which of these expressions in parentheses have the greatest number of terms. And this one has 3. And because we're adding, I can put that on top. And the other thing I'm going to do is reorder these. Because I'm trying to get you to think like this. I want the greatest degree term up front. And remember, degree means exponent. And so I'll put here negative 8n cubed. I'm allowed to reorder these terms, by the way. It's not breaking any laws. Plus 2n squared. Okay, plus 7. And all I've done is rewrite this. And now here I've got 2n squared plus 8n cubed. So underneath here, I'm going to line these up. This is super important, really important actually. 8n cubed plus 2n squared. Now watch this. We're going to add. Okay, just like an addition problem. So 7 plus nothing is 7. Okay, and we'll put a plus sign in front of it. 2n squared plus 2n squared. Well, we don't do anything with the n squareds, so this is going to be n squared. We just add the coefficients. 2 plus 2 is 4. Okay, 4n squared plus, and now we do negative 8n cubed plus 8n cubed, and anything plus itself is, any, like negative 8n cubed plus 8n cubed, they're canceling out, so that's 0. This is just 0. And so my final answer here is just going to be 4n squared plus 7n. Or plus 7 rather. And that's it. So look, they've ordered it like I said. I wanted it ordered. in this answer choice. All right? Just in case you kind of want to see what that looks like, because I am trying to simultaneously preview the next section and sections thereafter. So we just go to y equals, put in 4x squared plus 7. Let's just take a look at it, see what it looks like. All right. So notice something. It's actually symmetrical. Okay, I want to zoom in. See if it captures it. There we go. It's symmetrical about the y-axis, and that's interesting. And it actually crosses the y-axis at 7. All right, if we look at our tables, we see when x is 0, y is 7. So that's just a preview. I just wanted you to see what it looks like. It's a curved line. When you have a squared term, it's curved. All right, so 4n squared plus 7. Okay. And that is number 17. Number 18. Let's see here. Oh dear. So, a couple ways to go about this. We can do this one of two ways. We can actually attempt to subtract this, or we could distribute this negative symbol through this parenthetical expression right here and add. And I promise you the second way is easier. Okay. Promise. So let's just distribute this negative, which is basically like multiplying each number by -1. We're just going to do this triple distribution right here. And I just want to rewrite this out to the side so I know what I'm doing. Okay, -1 times 5 is -5. -1 times -3x cubed is +3x cubed. And -1 times 6x squared is -6x squared. Okay, so what I'd like to do at this point is just reorder this with the greatest degree up front. So we can rewrite this this is equal 3x squared, or 3x cubed, minus 6x squared, minus 5. Okay? And now we'll stack it. Let's write in our work down here, 3x cubed minus 6x squared minus 5. And now we'll stack add. Now this one is 1 plus 8x squared. Well, I'm going to do 8x squared plus 1. They're the same thing, just reordering the terms. So here I'll put 8x squared underneath this x squared term. You want to keep these lined up. If you put this over here, it destroys the whole purpose. Plus 1. And now I can add like this. This is actually called adding polynomials, but we'll get to that. -5 plus 1 is -4. -6x squared plus 8x squared is +2x squared. And then 3x cubed plus nothing is 3x cubed. All right, so just another little preview. 3x cubed plus 2x squared minus 4. Okay, let's take a look at that. I'll have to zoom out. Hang on, I want to zoom out. See what this looks like. Okay, still don't see the whole thing. I want to zoom out a little bit more. I want you to see this. This one doesn't look quite like the one we just did before. It is, it's weird looking. Let me color this a little bit, just so you can see it a little bit more clearly. See how it curves like that? And that's called a cubic. Cubic because the highest degree is 3. And it doesn't look like the other one. It goes up and then whoop, and then goes up again. So that's just, again, I want you to see what they look like, so you know that there's some meaning behind what you're doing. All right, let's go figure out what the answer is here. I'm looking for a 3x squared, a 3x cubed, a 2x squared, and a minus 4. Here's a 3x cubed. Okay. I want a 2x squared, positive, and then I want a minus 4. All right, so here it is, right here. See, look at this problem, did it right. It put the cubic up front, then the quadratic, and then the number. All right, so that's number 18. We're on our way to 20, just coming up. Okay, here's number 19. Uh-oh, we got to do some distributing here. So I guess I'll distribute this 4. This time we're not simplifying, we're actually going to solve, because you see the equal sign. And then I'll have to distribute this negative 8. Okay, let's do this. 4 times 8x is 32x. And 4 times negative 5 is negative 20. I know that some people have adopted the protractor or credit card or ruler. I love these little transparent protractors because they give me something to grip with my fingers. And the reason I use it, I'm not trying to be difficult, okay? I would promise I wouldn't try to be difficult ever, but it keeps the line straight. Okay? Straight lines, it makes it so much easier for your brain to process what you're seeing. So that's why I do it that way. Let's go ahead and keep this in parentheses for now. Parentheses don't really do anything other than kind of separating in your mind. Now let's look at this one here. Negative 8 times 6x would be negative 48x. And negative 8 times 3 is minus 24. And again, I'll put these in parentheses. You'll see why in a moment. Equals negative 8x minus 8x. So there's the whole problem. And the reason I put these in parentheses is because we can actually add them, right? And that it's not required that you do it this way. I mean, you could just leave the parentheses out and solve the equation by slowly adding numbers to both sides or subtracting numbers from both sides until you get x by itself. But this is a step that if on this left side of the equation, we can combine the terms together and make our problem a little bit easier, which is always a good thing. So here on the make some room, leave room, because you're going to need to come back up here and actually solve the problem. But leave a little room, come down here, a little tiny side work down here. Actually, I want to leave room, so I'm going to come up here and do this side work. I want to run out of space. All right, so we're going to add here 32x minus 20 to negative 48x minus 24. It looks like a subtraction problem, but it isn't. There's a plus sign over here. So watch how I do this. Negative 20 plus negative 24. Let me do it again. Negative 20 plus negative 24. It's going to be a bigger negative number. That'll be negative 44. All right. 32x plus negative 48x. That is like subtracting 32 from 48. So a little side work here. 48 minus 32. The answer is going to be negative. 8 minus 2 is 6. 4 minus 3 is 1. And there's a negative sign. So we bring down this x here. And then we put negative 16x. All right, so we simplified the left side of the equation only. Forget about the right side for a second. From this mess to this nice clean little binomial. So now we'll rewrite this as negative 16x minus 44 equals negative 8x minus 8x. Right? We can actually clean up the right side a little bit now. Negative 8x minus 8x, those are common terms, like terms. So we can say negative 8x minus 8x. Well, that's just negative 16x. So a quick rewrite before we really get into it. And you'll see we've kind of simplified the problem quite a bit. Let's just rewrite the left side. Negative 16x minus 44 equals negative 16x. All right, so we're getting there. Let's add 16x to both sides. Watch what happens here. You got to be careful. Negative 16x plus 16x is 0. Negative 16x plus 16x is 0. And so now we have a weird situation. We have negative 44 equals 0. That is not true. The symbol for not equals in math is an equal sign with a little diagonal line through it like that. Negative 44 does not equal 0. There's no math that we can do to fix this, so there is no solution to this problem. Okay? So you should write no solution. I hate these problems when they come up because you're like, what do I do now? Right? But it's just no solution. Now I'll verify that real quick. I'm pretty sure we're right. Just want to make sure so we don't leave it. Yep. So there's no solution. Okay. And that was number 19. Okay, last problem of the second set, number 20. All right, number 20. Let me finish off this cup of coffee here. If I follow that pattern, I'll drink 5 cups of coffee while making this video. Unbelievable. Okay, so number 20. We got distribution to do here. We'll distribute the negative 7. And then we'll distribute the negative 2. Let's do that. Let me just make this clear. All right, we're over here. Negative 7 times v is negative 7v. Negative 7 times negative 1 is positive 7. Equals. Negative 2 times 4 is negative 8. Negative 2 times negative 4v is positive 8v. Okay? Well, we just want to get the v by itself, right? So you could do it by subtracting 8v from both sides, or you could do it by adding 7v to both sides. I'm going to choose to add 7v to both sides because I don't like to deal with negative numbers. It's just one more cognitive hurdle. Again, you could do it the other way. You'll get the same answer, but v will be solved on the other side of the equation, which is fine, doesn't matter. Okay, so negative 7v plus 7v is 0. 8v, positive 8v plus 7v is positive 15v. And now let's rewrite what we have. We have 7 equals negative 8 plus 15v. Okay, now what do we do? Well, we got to get rid of the v by itself so we can add 8 to both sides. And remember, I'm adding 8 here because we had a negative 8. So I have to do the opposite thing. Whenever you see this, see negative, positive. Okay? And the other side doesn't matter, but the first side matters. So we have here on the right, negative 8 plus 8 is 0. And on the left, 7 plus 8 is 15. So now let's rewrite. We have 15 equals 15v. Okay? Remember, this is 15 times v. So we'll do the opposite thing to get rid of it. Get v by itself. We'll divide both sides by 15. Okay, on the right, the 15s cancel. Because 15 divided by 15 is 1. And then on the left, the 15s also cancel. But keep this in mind. I'll see people write v equals 0. There are little ones left behind when you do this. So really, it's 1 equals v. Right? And that's number 20. So before I close out this section, I'm going to take another break. Right? I'm going to keep it running, right? First, 2 reasons. One, I don't want to have to edit this video, okay? If you've ever tried to edit a video, you've got to put it into a video editor, and if you make even one small change, you have to re-render the entire video. And a video of this size is going to be several gigabytes of data, because we're already at an hour 39 minutes. I just keep it running. The second reason is because I want you to know that this is like a live session. This is me sitting here as long as it takes. You know, I started recording this thing at like 9 or 8:45 a.m. And guys, I realized last night, we had 3 volleyball games and a major football game. By the way, what a massive win for us. Incredible. It was a very good game. And then the JV team won on the volleyball side of things. But I do want to say that varsity played very well. Didn't get to see much of that because I was doing ticketing. But I saw the freshmen play. That's my people here, right, listening to this video. And I want y'all to know something. Amazing work. Okay, amazing, amazing work. I think it was the second set that y'all won. What incredible teamwork. I don't want to say students' names on this video, but there are a couple of students. All of y'all work very well together, but man, I wish I could say some names. One student's name starts with an A, and one student's name starts with an S. Another student starts with another A. There's another A in there. There's an M. Okay. Now, if I'm not mentioning your name, it's because I can't think right now. But y'all, there were a couple people in there who absolutely dominated. I can tell that this freshman team is going to become a dominant JV team, and that this is volleyball, and the JV team is going to become a dominant varsity team one day. So I am so proud of how y'all keep it real and keep the heat on in class and out of class. Make me very, very proud. It shows that competitive spirit. So all of that is in service of, I know you're tired, okay? As much as I was screaming and hollering and yelling, cheering you on, I know that isn't 1/50th as hard as actually playing the game. You guys must have gone home just dead last night. My JV football players and my one varsity football player, I know y'all are exhausted as well. Nobody wants to be doing math on a Saturday before a dance or a Sunday, after church or whatnot, trying to rest and relax. I promise, though, I feel the same way. So what you feel is what I feel. I feel tired. I feel exhausted. I can barely speak. My voice sounds weird on this video, but we got to keep trucking along, don't we? Even though you won the game, coach is going to make you show up to practice the next day, right? There's no rest. That's good, though. It builds character. It builds strength. It builds endurance. And I want to say character again. It builds character. The fact of the matter is, in the real world, if you have a really hard day at work, I mean, I'll tell you, I feel it every day sometimes. You have a really, really hard day at work, you have to go in the next day and work hard again. It gives you a purpose in life. I mean, you feel tired, and it's that wonderful exhaustion that you feel after working really hard. That is the payoff for me. I mean, it sounds sadistic, right? I love the pain, but it's kind of like that workout pain. You go work out real hard, you're exhausted, you're beat, and then you feel almost euphoric. You feel like good from working so hard. So that's how we do it here. So let's take a break here, guys. I'm going to keep the video running, but I'll put Mr. William Shakespeare, back up for us, and we'll come back here in a few minutes. You'll know we're back when I move this thing. Okay. Okay, folks, we are back. We are back, folks. Okay, we finished our second set. We're 2/5 of the way done. Okay, and we're moving on to number 21. Okay, this is easier than it looks. Let's see what number 21 is asking us to do. We are asked to evaluate each using the values given. This is just plug in the numbers, all right? So let's write this out. We've got n plus n plus m. Okay, and what we want to do is substitute in 4 wherever we see an m and 3 wherever we see an n. And so we'll plug in 3 for n, so 3 plus 3 plus 4. It's that simple. So what is 3 plus 3 plus 4? 3 plus 3 is 6. 6 plus 4 is 10. Like I said, some of these are going to be real easy. So answer to number 21 is 10. Number 22, we are given the same type of instruction here. So let's just rewrite b minus a over 2. And wherever we see an a, we'll put a 2. Wherever we see a b, we'll put a 4. So that's just, see, b was 4, so 4 minus 2 over 2. And that equals 4 minus 2 is 2. 2 over 2. 2 over 2 can be reduced to 1. So number 22 is 1. Those were quick. Number 23. All right. Paper tiger. Paper tiger means something that looks hard but isn't. We got this. So here we're multiplying all of this, and we're just going to apply the product rule. So we'll actually just end up adding 3 plus 3 plus 4, and we multiply the coefficients together. Watch how easy this is. 6 times 4 is 24. And now n cubed times n cubed times n to the 4th power. Well, that's just n to the 3 plus 3 plus 4. So 3 plus 3 is 6. 6 plus 4 is 10. So it's 24 n to the 10th. And that was that easy. And that's number 23, 24 n to the 10th. Number 24. Okay, number 24, we've got here, again, x's. So same base, we can use the product rule. Over here, we'll do our product rule just so we know what we're doing. We've got x to the 4th times x cubed. So that's x to the 4 plus 3. And that equals x to the 7th. Now we just multiply the coefficients together. 6 times 7 is 42. So it's 42 x to the 7th. And that was number 24. Okay, we've gotten through those pretty quickly. All right, now we're moving on to number 25. Same instructions, we're just going to simplify. Okay, so here we're going to apply the product rule first and then the quotient rule. In the numerator, we've got 3 n squared times n squared. So that's really 3n to the 2 plus 2. 2 plus 2 is 4, so we have 3n to the 4th power in the numerator over n. Remember, n has an exponent of 1. So now we'll apply the quotient rule, which is we're going to subtract these exponents. So this is equal to 3n to the 4 minus 1. 3n to the 3rd power, 3n cubed. And it was that easy. Number 26. We've got n squared over 6n to the 4th power times 5n to the 4th power. So now we're going to apply the product rule in the denominator before we do the quotient rule. So let's rewrite the numerator, n squared. And let's multiply these coefficients. 6 times 5 is 30. And then n to the 4th power times n to the 4th power, we add the exponents, so that's 30n to the 8th power. Okay? So let's do this over here. Side work, we have n to the 2nd over n to the 8th. And that is equal to n to the 2 minus 8. 2 minus 8 is negative 6, so that's equal to n to the negative 6. And now we use the 0 exponent rule. N to the negative 6 is equal to 1 over n to the 6th. Okay? So we've gotten rid of these. So we just write equals 1 over 30 n to the 6th. And it was that easy. Number 27. Okay, find each product. It's just distributive property. Let's draw our distribution lines. We'll distribute 5x squared through each term of the parenthetical expression. All right, so we're going to be multiplying the coefficients and then doing the product rule for the exponents. And here, just so we don't get lost in a blizzard of numbers, remember that x has an exponent of 1 right there. Okay, so let's take this one term at a time. 5x squared times 8x squared. 5 times 8 is 40. X squared times x squared is x to the 4th power. Plus 5x squared times 3x to the 1st. 5 times 3 is 15. X squared times x to the 1st is x to the 2 plus 1, that's x cubed, x to the 3rd. Plus 5x squared times 8, 5 times 8 is 40. And then we write x squared. Okay, there it is. So let's find that. Here it is right here. Not hard at all. Okay. Let's move on to number 28. Let me put this down. Number 28. Number 28, we are given another one of these. This time it's with subtraction. We will distribute the 8r squared to each term in the parenthetical expression. 8r squared times 5r squared. 8 times 5 is 40. R squared times r squared is r to the 2 plus 2 using the product rule of exponents. So that's 40r to the 4th power minus 8r squared times 3r. 8 times 3 is 24. R squared times r. Remember, r has a 1. So that's r squared times r to the 1st. So that's 24r cubed, or r to the 3rd power. And now 8r squared times, should put a minus sign here, 8r squared times 7. 8 times 7 is 56. And r squared comes along for the ride. Let's find that one. I spy it right here. 40r to the 4th minus 24r cubed minus 56r squared. Okay, and that is number 28. Okay, moving on to number 29. We're flying through these, guys. Number 29. Okay. So, solve each proportion. In these two problems, I'll show the two different methods. One of them will be the butterfly method, and one of them will be the common denominator method. All right, so I know that there is a preference for one or the other. I want to show both methods in these two problems here so that you have a chance to see how they both work. In these two problems, the butterfly method is probably the simpler way to do it. But as you know, when we start solving rational equations and we have multiple fractions on either side of the equal sign, you have to find a common denominator. So I'll just preview that with this problem, but here we'll do the butterfly method because this is something that y'all are comfortable with. And, you know, I had never heard butterfly in my life until last year, and then the kids told me, oh, butterfly method. And I think that's neat. So we'll take here 9, open parentheses, a plus 1, close parentheses, equals 7, open parentheses, a plus 5, close parentheses. Now we just got to do distribution on both sides. So we'll distribute 9 to this expression, and then we'll distribute 7 to this expression here. 9 times a is 9a. 9 times 1 is positive 9, equals 7 times a is 7a, and 7 times 5 is 35, positive 35. Okay, so we're going to solve this for a. We'll solve for a on the left. Again, we could have chosen to do it otherwise, but this keeps us away from negative numbers. So I'll subtract 9 from both sides. 9 minus 9 is 0. 35 minus 9. Let's borrow here. 15 minus 9 is 6, and then 2. Okay, so let's rewrite. We have 9a on the left equals 7a plus 26. Now what do? Well, we want to get a by itself, so let's move this 7a over to the left side. Because it's currently positive, we'll subtract 7a from both sides. (9a minus 7a is 2a. 7a minus 7a is 0. So now, down to the final step here. 2a equals 26. And to get rid of the 2, remember 2 is multiplied by a, so we'll just divide both sides by 2. On the left, the 2's cancel, leaving a by itself. A is equal to 26 divided by 2, and 26 divided by 2 is 13. So a equals 13. All right, and that was 29. Okay, number 30. So in number 30, I was going to show that other method. Please know that you could use butterfly here, but again, in this simple problem, it's probably easier to use butterfly, but we're about to get into some stuff here in a minute, later in the year as well, that it can't be done butterfly method. You got to find a common denominator. So the common denominator here between 10 and 5 would be 10. That would be the lowest common denominator, the LCD. And that means we'll have to multiply something by 5 to make it turn into a 10. And so we have to do this little step here of multiplying the right side of the equation by 2 over 2. Right? And just to be careful, I'm going to put these expressions in parentheses. And that also helps us because we know that that means we have to multiply the 2. Okay, so let's rewrite everything. On the left side, I have k minus 1. I'm putting it in parentheses just as a protective measure over 10 equals. Now let's distribute multiply. 2 times k is 2k plus 2 times 9 is 18. Okay, put that in parentheses over 10. So now we have this cool situation. So I was calling it the throat punch. This is a cool method here. We've got the same denominator on both sides of the equal sign. And that means we can multiply out the denominator completely. On the left, I can multiply by 10. Notice where I put the 10. I put the 10 in the numerator position because what I'm really doing is multiplying by 10 over 1. Okay, so now I'll multiply by 10 over 1 on the right. Sometimes you'll see me not write over 1 because it's kind of understood. On the left side, the 10's cancel, and on the right side, the 10's cancel, just like that. And that is a beautiful algebraic trick that leaves us with just the numerators. K minus 1 on the left. I don't need the parentheses anymore. Equals 2k plus 18. All right, so now I'm just solving this. So I'll solve for k on the right by subtracting k. Remember, this is 1k. Okay, and then over here on the right, I'll subtract out 1k. On the left, 1k minus 1k is 0. On the right, 2k minus 1k is just k, or 1k, right? So now on the left, all I've got remaining is negative 1 equals k plus 18. Now, we want to get k by itself on the right. So I'll subtract out 18 on both sides. On the right, 18 minus 18 is 0. On the left, negative 1 minus 18. You add them together and put a negative sign in front of it, okay? So 1 plus 18, 19. That's negative 19. So negative 19 equals k. All right, so here's the two methods, right? This was the, I should probably call it something besides the throat punch method. This is the common denominator method, all right? And this is the butterfly distributive property method. They both work, okay? They both work. Some situations call for the butterfly method, or it's whatever's easier, right? And then some situations call for the common denominator method. Okay. And I mean, if you master both methods, you can use them whenever you feel most comfortable. All right, and that was number 30. All right, so we've hit another milestone here. We've only got 20 left. That's 2 more sets. So keeping to our strategy here of taking breaks, it's kind of like quarters in a football game or innings in a baseball game. We got 5 innings in this game, or 5 quarters in this game. So we're going to take another break, and y'all go get something to drink. I'm going to drink some more coffee. I'll be anything, if I'm anything by the end of this, I'll be wired. And we will be back here, probably be a shorter break this time, but we'll be back here in a few minutes, and we'll see you then. Okay, and we are back. It's a shorter break this time. Okay, so we're moving on to number 31. Uh-oh, I see square roots. It's no big deal. So it says solve each equation. All right, remember to check for extraneous solutions. We'll show you how to do this. Let's just write it down first. 10 equals the square root. Okay, that's where the protractor really helps. You see, the square root of 20b. All right. How do we get rid of the square root? Remember, we're solving an equation, so we still want b by itself. So we have to get rid of the square root. So how do you get rid of a square root? Well, here's how you do it. You square everything. Watch how I'm doing this. Put parentheses around the whole thing, the whole square root, and then what you do to one side, you have to do to the other. So put parentheses around the 10, and now square both. And that gets rid of the square root. Okay? Let me show that here. So I'm going to write 10 squared equals, and now I've gotten rid of the square root. So I just write 20b. Okay? Now I will divide out the b, or rather divide out the 20. I'll solve for b on the right. So we'll divide both sides by 20. Now I need to cross out these 20s, and I have to divide 10 squared by 20. Well, 10 squared is just 10 times 10. So that's 100 over 20 equals b. Right, so one real quick simplification is to just get rid of the zeros. And now we have 10 over, pardon me, 10 over 2 equals b. 10 divided by 2 is 5, so 5 equals b. Now here's a little rule about square roots that we have to remember, okay? The square root of these numbers, one second for me. I gotta clear my throat a little bit. All right, and we are back with number 31. Okay, so let's do number 31 here. In number 31, we're presented with square roots. All right, and that can be a little bit of a challenge, but we'll be able to deal with it, no worries. I want to show you, for number 31 and number 32, I'll show two methods. One method is the kind of the simpler method, and the second method will introduce a new concept called the power rule of exponents, so I can show you how things will eventually become. So this is the simple method. Like before, we did one problem with butterfly and then one problem with the common denominator method. In these two problems, I'll again show two different methods. Again, with these two fairly simple problems, this first method might seem easier, but as we move forward in Algebra 1 and of course into geometry and Algebra 2, pre-calculus, things like that, calculus, the second method I'll show with the power rule, that'll become the standard method to solve. So let's take number 31. We are given 10 equals the square root of 20b. Okay? And the question is, how do I get b by itself? Right? Well, here's the way. You are going to put both the left and right side in parentheses, and because this is the square root, which is the second root, we can simply square both sides of the equation. And that has the effect of deleting the square root symbol. And this is a simplistic answer to the simplistic explanation. But again, it only works when it's square root like this. So we have on the left 10 squared. Just follow along with me. I know this is a bit of a preview and not so much of a review. 10 squared equals 20b. See, we got rid of the square root. And now we can just divide both sides by 20. On the right, the 20s cancel. I got b by itself. And now 10 squared, that's 10 times 10. And that's 100. I got 100 over 20 equals b. Now we reduce this fraction. 100 divided by 20 is 5. So 5 equals b. Okay? Number 32. Okay, number 32, I'll show the other method, the power rule method. But you could solve number 32 this way. So like I said, in this set of problems, this is the simpler method. I want to show this, I want to demonstrate this more rigorous method because it's coming, and I want to just demonstrate it here for you. 4 equals the square root of 2 minus 2r. All right? So here's how this works. Over in side work, we'll have a little mini lesson on the power rule. So in the exponent rules, so far we've learned the product rule, the quotient rule, and the zero exponent rule. Okay? Here, not the zero exponent rule, the negative exponent rule. So here's a new rule. This is called the power rule. This is a cool one. When I was growing up, the big TV show was the Power Rangers back in the early 90s. And so I always thought this was cool. And, well, nerding out on you guys here, but We used to wear costumes when we were kids, dressed up as the Power Rangers, and I was the Green Ranger. I think his name was Tommy. Yeah, anyway. So if you're a Power Rangers fan, if you're into that, what is now vintage television, you'll know what I'm talking about. So, what is the power rule? Well, here's the power rule. X to the A raised to the power. Okay, that's how we do it. We put in parentheses and then we put up here the B. So x to the A raised to the power of B equals x to the A times B. Okay? So before we were adding, when we were multiplying bases, well, now we're raising one base with an exponent to a different exponent. So we multiply the exponents. All right, so this is different than the product rule. Now here's one other thing we need to know. The square root of a number, like x, can be rewritten as x to the 1/2. I want to show why that is, because some people want to know, how did you do that? Well, it's like this. This is the square root, which means this is the second root. The 2 is not written, it's just understood. And the x is understood to have an exponent of 1. All right? So the way this rule works, like with letters here, is the nth root, whatever that is, of x to the m power. And folks, if you're watching this saying, what is this fool talking about? Just watch. We're going to get into this. This is more of a preview. I'm just demonstrating something here. I want you to watch and kind of follow along. The nth root of x to the m is equal to x to the m over n power. All right, so let's follow the logic here. This is the second root of x to the first. Okay? So we wrote it x to the 1 over 2. This 2 was the n, and this 1 was the m. All right, so we raised x to the power of m over n. And I'm just trying to expose you to this. It's something that you will get comfortable with later. All right. So now that we have our work here, let's go back to our problem. All right, so here's my first step. My first step is to convert this square root, and remember, that's the second root, and everything underneath the square root has a parentheses around it, and that whole expression is raised to the power of 1. Okay, so I'm going to convert my root into a parenthetical expression with an exponent. All right, so watch. 4 equals, open parentheses, 2 minus 2r, close parentheses, and now we're going to raise that to the m over n. So this 1 is the m, and this 2 is the n. So we raise it to the 1/2 power. Stay with me. Just follow the logic of the problem. So we don't have to do that to the right, the left side, because we haven't changed anything. This is simply these equal one another. All right? We haven't changed anything. We've just rewritten it in a different way. This is literally identical to this, okay? But for our purposes, we need to rewrite it like this. All right, so remember, practice comes first, understanding comes second. You got to practice the process first. You'll understand later. Now, I need to get rid of these parentheses, which means I've got to get rid of the exponent right here. And the way I'll do that is by squaring both sides of my equation, right? Now I know this looks scary and hideous. It looks like we've made it harder, but we haven't. So on the left, I'll just write 4 squared equals. In my side work here, I want to show what's happening on the right side, so we all understand what I'm doing. I've got open parentheses 2 minus 2r raised to the 1/2 power. Okay? Now what I'm doing, I'm going to apply the power rule here, because this whole thing is raised to the 2nd power, like that. So what this means is, this is, according to the power rule, this 1/2 right here, this is the A, and this 2 right here, this is the B. Okay, so it says here, if you have A raised to the B power, you multiply A times B. So we'll go over here and rewrite open parentheses 2 minus 2r raised to the, and we're going to multiply them together, raised to the power of 1/2 times 2, which we'll write as 2 over 1. 1/2 times 2 over 1. Now look what happens. 1/2 times 2 over 1 is equal to 2 over 2, which is equal to 1. Right, so now I'm going to rewrite this. This is equal to open parentheses 2 minus 2r raised to the power of 1. And everything's raised to the power of 1 by default, so we don't have to write it. We can just write 2 minus 2r, which means we got rid of the parentheses. Now I know, look at the two sides here. This, quick, oh God, look at this. Look at this nightmare over here. So clearly, this is the method to use when the problems are simple, and the root is 2. It's pretty simple. You can just do square both sides, all right? And that gets rid of the square root. But this is the more rigorous method. By the end of the year, okay, I promise you'll be super comfortable with this. We're going to practice it until it's just second nature. It's like walking or riding a bike. So let's go back to our problem now. We have completed using the power rule here in our side work. Okay, we multiplied 1 over 2 times 2 over 1, and we got 1. And so we can just write 2 minus 2r. Okay? So now we'll just say what's 4 squared is 4 times 4. That's 16. So 16 is equal to 2 minus 2r. Now I'll subtract 2 from both sides. And I have 2 minus 2 is 0. And 16 minus 2 is 14. And now I have 14 equal to negative 2r. One final step. Divide both sides by negative 2. And I get negative 7 equals, these negative 2's cancel, equals r. Okay? So again, I fully understand that This was shocking in its complexity, but understand something, this is coming, and we're going to practice it. So this was just a preview. So this is -7. And that is number 32. All right, we'll move on to number 33 now. Okay, number 33. Suddenly, we went from extreme complexity to extreme simplicity. We have -4 equals 5 plus m. So all we have to do is subtract 5 from both sides. -5 minus 5. -4 minus 5 is -9. 5 minus 5 is 0. So I have -9 equals m. All right. And now I've got number 33 done. Moving on to number 34. We have -8 v, that's -8 times v, equals -16. Okay, so we're going to get v by itself by dividing both sides by -8. The -8's cancel. We have v equals -16 divided by -8, and that's just 2. v equals 2. Alrighty. And that's number 34. Moving on to number 35. All right. So this is going to be multi-step. Well, first we'll start by applying the distributive property where we see that it can be applied. Draw in our distribution lines here. And now let's go through it. -6 times p is -6p. -6 times +8 is -48. -2 equals -7 times 1 is -7. And -7 times +7p is -49p. Okay, so we got to solve for p. And I don't, I want to make my life easy. So I'm going to add 6p to both sides. You could have done it the other way, either way. All right. -6p plus 6p is just 0. And -49p plus 6p, we're basically subtracting 6 from 49. Let's do that. 49 minus 6. 9 minus 6 is 3. Bring down the 4. -43. So this is -43p. So let's rewrite what's left. On the left side, I have -48 minus 2 equals -7. minus 43p. And I'm continuing to isolate p. Over on the left side, I should go ahead and subtract 2 from negative 48, and that would give me negative 50 equals equals negative 7 minus 43p. And now I will add 7 to both sides. On the left side, negative 50 plus 7 is negative 43. On the right side, negative 7 plus 7 is 0. So now I have negative 43 equals negative 43p. Final step, divide both sides by negative 43. On the right side, these negative 43's cancel, and they also cancel on the left side, leaving behind 1, in their place. So P equals 1. Cool. And that was number 35. Number 36. Okay. Number 36, we've seen this problem before, or a problem like it. Apply the distributive property. And we've got 8 times negative 1, that's negative 8. And 8 times a, that's plus 8a, equals 6 times 2a, that's 12a, minus 6 times 2 is 12. 12a minus 12. Okay, so we'll group terms together and get a by itself. I'll start by subtracting 8a from both sides, so I stay in the positive territory. On the left side, 8a minus 8a is 0. On the right side, 12a minus 8a is 4a. So now on the left side, I have negative 8 equals 4a minus 12. Okay, so now I'll add 12 to both sides. On the right side, negative 12 plus 12 is 0, and on the left side, negative 8 plus 12 is positive 4. So now I have 4 equals 4a. Divide both sides by 4. Right? And all the 4's cancel again, leaving behind 1's. So 1 equals a. And that was number 36. Number 37. All right, number 37, we're given 5 equals negative 4 plus a over 3. Okay? Key step right here, put this in parentheses, the numerator. Put the numerator in parentheses on the right side. And now we're going to multiply both sides by 3 over 1. and that allows me to cancel the denominator on the right. And on the left side, I just have 3 times 5, which is 15. So 15 equals negative 4 plus a. Okay, so I'll add 4 to both sides. 15 plus 4 is 19. Negative 4 plus 4 is 0. So I have 19 equals a. And that's number 37. Number 38. Okay, same solution process as 37, but on the other side of the equal sign, we got negative 1 plus a over 15 equals 1. Okay, step 1, put this in parentheses. And now multiply out the denominator on both sides. Here I'll leave off that over 1 notation. You need to start knowing that that's what that is. You need to make sure this 15 is in the numerator position when you multiply it. Well, that allows me to cancel out the 15s. And now I've got negative 1 plus a equals 15. Okay, so I'll just add 1 to both sides. On the left side, negative 1 plus 1 is 0. And on the right side, 15 plus 1 is 16. So a equals 16. And that is number 38. Number 39, we're rounding the bend here on getting done with this second to the last problem set. It asks us to simplify each expression, so there's nothing to solve here. We're just going to simplify each expression. We're actually going to use something here called reverse distributive property or reverse distribution. And here I want to show you off in side work kind of what I'm talking about. Let's take this numerator here, 3b squared plus 3b. Put this in parentheses and try to factor out a number from both the terms inside the parentheses. Well, check this out. We're going to do reverse distribution. So for the number, I could factor out a 3. Just watch how I'm doing this. Okay, reverse distribution from both terms. So there comes a 3. And I could factor out a b, because this is b squared, which is just b times b, and this is a b. So I can pull a b out of both terms. And now I've got a b. And what that leaves me with is 3b, open parentheses, b plus 1. Because what I basically did was divide out a 3 and a b from both things. So 3 divided by 3 is 1, so that, and b squared divided by b is b, so that gives me b. Okay, and then 3b divided by 3b is 1, so that's how I got the 1. Right, so that is the key step. This is called factoring. But I like to think of it as reverse distribution. Because you could always multiply this back in and get back to your original. 3b times b is 3b squared, and 3b times 1 is 3b, and you get right back to your original expression. So we factored it, okay? So we'll practice this a lot more, but that is what we're doing. So in our problem number 39, we've got 3b squared plus 3b over b plus 1. And that is equal to this factored form on top, which is 3b, open parentheses, b plus 1, close parentheses, over b plus 1. And let's put that b plus 1 in parentheses because now it'll be clear. We can cancel out the b plus 1s, okay? And that simplifies this whole expression down to just 3b. That's number 39. Final problem of this set, number 40 coming up. And now to number 40, all right? So here we are, we're given 21 n squared minus 28n over 63n cubed. Okay, so we're going to factor the top, which is reverse distribution. I'll do it up here. I got 21n squared minus 28n, 21n squared minus 28n. Put that in parentheses. And then you're going to pull out the greatest common factor of 21 and 28. All right, so what is the greatest common factor of 21 and 28? It would be 7, right? Because 21 is 7 times 3, and 28 is 7 times 4. So we can pull out a 7. And we can pull out an n. Okay, just one. So I'm going to pull out a 7 from 21. And I'm going to pull out an n from n squared and n. So I'll pull out a 7 from 21 and 28, and an n from n squared and n. And I'll show you another way to write this so you get a better understanding. What I'm really doing is dividing both of these terms by 7n. Okay? So my simplified expression is 7n, open parentheses, and then 21 divided by 7 is 3. N squared divided by n is n, minus 28 divided by 7 is 4. N divided by n is 1, so I don't have to write anything. Close parentheses. And that's the factored form of this. Okay? It's reverse distribution, because you could always multiply 7n back in, and you would get your original expression. Okay? So, we should also look at 63 n cubed. We'll do that in a second. I'll tell you what, let's just write this. So, this whole monster right here is now been simplified to 7n, open parentheses, 3n minus 4, close parentheses, over 63n cubed. So now it's time for us to look at the 63 n cubed. And let's think about how we could rewrite that. 63 n cubed. What I'd like to do is find a way to get 7n out of that. So if I divided 63 n cubed by 7n, what would I get? 63 divided by 7 is 9. N cubed divided by n is n squared. Okay? So that means I can rewrite. Let me rewrite the top real quick and we'll get to the bottom. 7n, open parentheses, 3n minus 4, close parentheses, over. Now I want to write this because I want to try to simplify. I want to write this as 7n times 9n squared. And if you look at it for a minute, you'll see 7n times 9n squared is the same thing as 63n cubed. Because 7 times 9 is 63, and n times n squared is n cubed. But writing it this way allows us to cancel out the 7n's. This is such a cool problem. I love this. So what's left? Well, what's left is 3n minus 4 on top over 9n squared on the bottom. All right? And that's the answer, or the simplified expression. This equals this. It's just simplified. All right, well, that is number 40. We are in the home stretch. And we'll take a break here. Probably a good 5-10 minute break here, and we'll come back and finish it up. Y'all take a break, please. Give yourself a break. Walk around, get something to drink. Be back shortly. All right, everybody, we are back. We are back and we are moving on to number 41. Okay, we're down to the final 10 problems, okay? It's like, you know, where it's the final countdown. Okay, no more singing. It's not something I'm good at. All right. So number 41, ladies and gentlemen, let's get this done. We'll knock these final 10 problems out. So we are given 1 over 4v squared equals 1 over 8v squared plus 1 over 8v. Okay? And so here is a place where we need to use the greatest common factor method instead of the butterfly method, because on the right we've got two terms, see? And they have different denominators. So we have to think, what do I need to multiply by 8v to make it 8v squared? And then over here I think, what do I need to multiply by 4v squared to make it 8v squared? So on the right, I need to multiply 1 over 8v by v over v. And on the left, I need to multiply 1 over 4v squared by 2 over 2. Okay? So now I've got 2 times 1 is 2 over 2 times 4 is 8, and v squared comes along for the ride, 8v squared equals 1 over 8v squared plus 1 times v is v over 8v times v, which is 8v squared. So now I have common denominators everywhere. I can combine these. So on the left, I'll write 2 over 8v squared equals, and then this can go big fraction bar here, 1 plus v. Don't combine them. It's not 1 times v, it's 1 plus v. It's got to stay just like that. In fact, put it in parentheses. Over 8v squared. Okay, and here we could use like a hybrid approach. We could apply butterfly at this point. I just want to show you that this is possible to kind of mix the two methods. So here we'll do butterfly right here and right here. So what have I got on the left? I've got 2 times 8v squared equals 8v squared, open parentheses, 1 plus v, close parentheses. So I need to distribute the 8v squared inside the parentheses. Okay? On the left, I have 2 times 8v squared, and that is 16v squared equals, and now I need to distribute 8v squared times 1 is just 8v squared plus 8v squared times v. Remember, v has an exponent of 1, so I'll use the product rule here. 8v squared times v to the 1 power is 8v to the 2 plus 1, which is 8v cubed. Okay, combine like terms. I'll get these v squareds together by subtracting 8v squared from both sides. Minus 8v squared. On the right side, I have 8v squared minus 8v squared, and that's 0. And on the left side, I have 16v squared minus 8v squared, and that is 8v squared. Okay? So let's rewrite what we have. We have 8v squared on the left equals 8v cubed. All right? So now what do we do? We are going to divide out the 8s. So I'll divide out the 8s real quick here. Divide out 8 on both sides, and those cancel out. Okay? And remember what I'm leaving behind. So I'm leaving behind 1s. Okay? This is going to be important here. Just want you to know that. Run out of space on the bottom of this page. So if you would with me, let's move this problem over. First, I'll move it up here. Just going to move this problem over a little bit. All right, so on the left side, I have 1v squared equal to 1v cubed. All right, so I want to get the v's by themselves. And this is 1 times v squared and 1 times v cubed. So I can divide both sides by the smaller exponent variable, which would be v squared. And remember, that's 1v squared. Now watch what happens here. 1 divided by 1 is 1. And v squared divided by v squared is 1. Right? So this whole left side is 1 times 1, which is just 1, equals. On the right side, I have to apply the quotient rule. V cubed divided by v squared is v to the 3 minus 2. And that's just v to the 1 power, which is just v. So my final solution is 1 equals v. Right? And that's number 41. All right, number 42. In number 42, we're given 1 over 9x squared plus 5x minus 2 over 9x squared equals 1 over x squared. So I have common denominators on the left, so I need to make this one say 9x squared over here. So I'll multiply the top and the bottom by 9 over 9. On the left side, I'll combine the numerators. So I'll just have one big denominator, one big fraction bar with 9x squared in the denominator. In the numerator, I have 1 plus 5x minus 2 equals 1 times 9 is 9. X squared times 9 is 9x squared. So I have common denominators. This time I'll use the cancel method. We will combine these terms here, 1 minus 2 and stuff. We'll do that here in a minute. First, we'll get rid of the denominators so the problem looks a little cleaner. I'll multiply both sides by 9x squared. Okay? And that allows me to cancel the denominator on both sides. So now I have 1 plus 5x minus 2 equals 9. Very clean. We can handle that. On the left side, I have here common terms 1 and negative 2. We can combine those together. 1 minus 2 is negative 1. So I could rewrite this as 5x minus 1 equals 9. So now I'm just solving this. I'll add 1 to both sides. On the left side, negative 1 plus 1 is 0. On the right side, 9 plus 1 is 10. So now I have 5x equals 10. I'll divide both sides by 5. Okay. On the left side, the 5's cancel. So I have x equals 10 divided by 5, which is just 2. X equals 2. Okay. And that is number 42. On to number 43. Okay, so more of the same with number 43 and 44. All right, so let's just write this down. 1 over 4a plus 1 over 2a squared equals 9 over a squared. So we got to think about the common denominator here because none of them are currently equal to one another. Well, the common denominator is going to require us to do a couple things. We have to multiply everything by something. So the way to do this is to think, all right, what do I need to do to the numbers? Let's just take the numbers part first. I have 4, 2, and 1. So the lowest common denominator part, number part of the lowest common denominator would be 4. Okay, so we're coming up with the LCD here, the lowest common denominator. And we've got a piece of it, it's 4. Now let's look at the letters. the lowest common denominator letter part would be a squared. So we need everything to be 4a squared. So that's going to require us to do some steps. Over here to the 4a, I need to multiply the top and the bottom by a. So I get 4a squared. For 1 over 2a squared, I need to multiply the top and bottom by 2. So I get 4a squared in the denominator. And then here on the right side, I need to multiply the top and the bottom by 4. Okay, to get 4a squared. So these are little mini problems we got to do. A times 1 is a over a times 4a is 4a squared plus 1 times 2 is 2 over 2a squared times 2, which is 4a squared, equals 9 times 4 is 36 over 1a squared times 4, which is 4a squared. So we have common denominators everywhere now. On the left side, I can rewrite this as a single fraction with 4a squared in the denominator, a plus 2 in the numerator. Don't say 2a, it's a plus 2. Put that in parentheses. Equals 36 over 4a squared. I promise you, it is simpler to use the greatest common factor cancel method here. The throat punch, the cancel method. This is going to make your life easier to just get rid of this 4a squared term entirely. So we'll multiply both sides by 4a squared. On the left side, the 4a squareds cancel out, and the same thing on the right side, 4a squareds cancel out. Now look how easy this becomes. I now have a plus 2 equals 36. And now I just have to solve for a by subtracting 2 from both sides. 2 minus 2 is 0. 36 minus 2 is 34. So a equals 34. All right? Number 44 is coming up next. All right, number 44, here we go. We are given 1 over k squared equals 10k minus 20 over 11k squared plus 1 over 11k squared. All right. So good news is we've got common denominators on the right. We only have to multiply the left side by 11 over 11 to get common denominators everywhere. Okay. So on the top, I've got 11 over 11 times k squared is 11k squared equals, and now I can combine my numerators on the right, 10k minus 20 plus 1 over 11k squared. And I'll go ahead and get rid of these denominators. Put this in parentheses so I don't mess up, put 11k squared, multiply that out on both sides, right? And I can cancel all those denominators now, which makes life so much easier. I have 11 equals 10k minus 20 plus 1. On the right side, I can do minus 20 plus 1, and that would be minus 19. So I'll rewrite 11 equals 10k minus 19. Okay? And now I'll just solve, for k by adding 19 to both sides. On the left side, I have 1 plus 9 is 10. We'll carry the 1. And so this is 30. And so on the right side, I have 0. So I now have 30 equals 10k. And I will divide both sides by 10 to get k by itself. Thirty divided by 10 is 3. And the 10's cancel. So 3 equals k. And that is number 44. Number 45. All right, it looks terrifying. It is not terrifying. Let's go ahead and write it out. K minus 6 over 3k squared plus 18k plus 1 over 3k squared plus 18k equals 1 over k squared plus 6k. All right. The good news is on the left, I've got common denominators already. On the right, I just need to make this be 3k squared plus 18k. And all I've got to do that is to put this in parentheses and multiply everything inside of the parentheses by 3. So I'm doing a little distribution problem here. Okay? So that will be 3 times k squared will be 3k squared plus 6k times 3 is 18k. And that's the same. That wasn't that hard, was it? On the left side, I put a fraction bar. Because I have common denominators, I'll put 3k squared plus 18k. And then up on top, I'll put k minus 6 plus 1. And I'll set that equal to 1 over 3k squared plus 18k. All right? No big deal, right? It was one step. Well, now I can do the same thing I've been doing for the last several problems. You see why now? Hopefully you see why now. I taught you that other method besides butterfly. Can you imagine if you had to distribute this into this? It would be pretty difficult. Watch how this works. So we're going to multiply both sides by this whole huge denominator here. 3k squared plus 18k on both sides. 3k squared plus 18k. Now watch how cool this is. This has got to be the coolest one of the day so far. Cancel, 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 cancel. So all that hard mess is just gone. It's just disappeared, right? So now all we have is k minus 6 plus 1 on the left side equals 1. Suddenly, calm down. Blood pressure goes down, heart rate lowers. We can handle this. Negative 6 plus 1 is negative 5, so I can rewrite k minus 5 equals 1. And then I just add 5 to both sides. And I've got a problem. I've got 0 here, and I have 6 here. So according to my math, k should equal 6. But 6 is not an option. Let's look at what we did here and make sure everything was correct. Okay, so I think it's right. Let's see if we made any mistakes. We had common denominators here. I mean, the answer choices could be wrong, So let's check. Maybe we made a silly mistake somewhere. Maybe you see it already and I don't. But let's see here. I got, I know what it is. I know what it is. I see the problem. I multiplied this by 3. I didn't multiply the numerator by 3. My bad. Don't worry, that doesn't change much. Do you see what I did? I went over here and broke one of the cardinal rules of math. I multiplied the denominator by 3 to get 3k squared plus 18k, but I forgot to multiply the numerator by 3. Okay, so let's go in and fix that everywhere. It's really not that big of a deal. So instead, this would be 3 instead of 1 now. Just a couple of little edits and we'll be on our way. So now this is 3. Okay, nothing changed about canceling all that cool stuff. So now all this is k minus 6 plus 1 should have equaled 3. My bad. Sorry about that. Getting a little tired. We're running for almost 4 hours here. It's okay. And so let's just edit this. All right. This should say k minus 5 equals 3. Okay, and then we would add 5 to both sides, and I'd have k equals 3 plus 5, which is 8. That's better. Sorry about that. This one little forgetfulness here led us down the wrong path. That's okay. That's why we show our work, right? If you turn this into me and you had made this mistake, I could go, oh, wait a minute, you forgot this, and then we could still get full credit. All right, so k equals 8. Mistakes happen. We're humans. All righty. So that's number 45. Number 46. Number 46, we are given this mess. And let's write it out. 3, don't worry, it's not going to be too hard. 3 over x squared plus x. Should probably extend this fraction bar out a little bit. 3 over x squared plus x equals 1 over x plus 1 plus 1 over x squared plus x. Okay, so notice I've got x squared plus x in two places. I need to make this denominator be x squared plus x. And now whatever I do, I'm going to multiply it by the numerator. And I'm going to make that mistake twice. So let me just sharpen up this pencil here. We're going to have to multiply 1 over x plus 1. Top and bottom are going to have to be multiplied by something. So let's put these in parentheses here, x plus 1, and think, what would I need to multiply through the parentheses in order to turn that x plus 1 into x squared plus x? If you're thinking, how about x, you are correct. Okay, so we'll multiply through by x on the bottom, and we'll also multiply the top by x, so I don't make the mistake I made over here again. So that'll distribute through. Let's rewrite the left side. I got 3 over x squared plus x equals x over, okay, x times x is x squared, and x times 1 is x. So x squared plus x plus 1 over x squared plus x. So now I have common denominators everywhere, okay? So I can combine the right terms now. I've got 3 over x squared plus x on the left equals, fraction bar here, x plus 1 over x squared plus x. Right, and now I can get rid of the denominator by multiplying both sides by x squared plus x. Right, and here's a cool thing. I can cancel, 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 cancel. My problem just became super simple. I have 3 equals x plus 1. To get x by itself, I just subtract 1 from both sides. Three minus 1 is 2. 1 minus 1 is 0. So 2 equals x. Okay? And that is number 46. Coming into the home stretch. All right. So we're moving on to 47. Literal equations. These are easy, right? Because you don't really have a lot of numbers to deal with. So here we've got u equals k plus a minus b. And it says solve for a. So just move everything over to the left side and you'll have a by itself. First we'll add b to both sides. Now look, u plus b is just u plus b. U plus b equals k plus a. Now to get a by itself, I'll just subtract k from both sides. And now on the left I have u plus b minus k equals a. Let's find a equals u plus b minus k. Okay, they've got them ordered a little differently. So what have I got here? We need a positive u, a negative k, and a positive b. Okay, here's a positive u, a negative k, and a positive b. So it must be d. A equals u minus k plus b. That's the same thing as u plus b minus k. All right? Okay, that was number 47. It's quick. Number 48. We're supposed to solve u equals k times a plus b for a. So here we go. U equals ka plus b. And remember, this is k times a. So we'll just do reverse order of operations here. Minus b on both sides. And now I've got u minus b equals k times a. I want to solve for a, so I'll just divide both sides by k. So now I've got the k's cancel over here, and I have u minus b over k equals a. So a equals u minus b over k, and that's this one here. And that's number 48. Down to the final two. All right. Here is number 49. And I'm supposed to solve this for a, and we got some numbers and some letters here. No worries, it's pretty easy. G equals 2b minus 6a minus 6. And it says solve for a. So I just want to get everything away from the a, right? First, I'll subtract out the 2b minus 2b on both sides. So now I've got g minus 2b equals negative 6a minus 6. So now I'll add out the 6 on both sides. And I've got g minus 2b plus 6 equals negative 6a. And now to get a by itself, I'll just divide both sides by negative 6. The negative 6's cancel. And so I now have g minus 2b plus 6 over negative 6 equals a. And in the answer choices, they have put the negative sign up here. Okay, so let's see what they're doing here. They've messed with us a little bit. So let's see what they've done here. They've multiplied the top and the bottom by negative 1. Yeah, that's what they've done. So if you look at our answer choices, we don't see this. They've done something a little tricky here. I wish they didn't do this to y'all, but they do. Whatever. So we got, if you look in the answer choices, we don't see a negative 6. All right. So let's do this. Let's multiply the top and the bottom by negative 1. So negative 1 times that and negative 1 times that. We'll just distribute and multiply the negative 1 through the top. You're basically just changing all the signs. And we'll multiply -1 times -6. Let's see what we get here. It's basically changing all the signs. You have -1 times g is -g. -1 times -2b is plus 2b. -1 times +6 is -6 over -1 times -6 is 6. Okay, and that's equal to A. Now let's go hunting for this one. -g plus 2b minus 6 over 6. So there it is, -g plus 2b minus 6 over 6. Tricky, it's tricky. And that was number 49. We're down to the final one. Here we go. Number 50. So we're about to round off 4 hours in the video. It's a long video, man. Number 50, I'm given u equals -6x over y. And I'm asked to solve for x. Okay, fair enough. Let's get rid of the denominator on the right side by multiplying the left and the right by y. And that allows me to cancel the denominator on the right. So on the left I have y times u equals -6x. If I want to get x by itself, I'll just divide both sides by -6. And now I've got the right canceling, and I have y times u over -6 equals x. And let's see what they want us to do here. All right. So I can see the answer. It's this one. But if you wanted to make it really look like that, you could just multiply the top and the bottom by -1. All right. And then you'd end up with negative. And what they want is, I guess they want the u to come first, because y times u is the same thing as u times y, -u y. And then -1 times -6 is +6, -uy over 6 equals x. And that would be this one, -uy over 6. All right. Well, we have come to the end, ladies and gentlemen. Look at all this work. Ugh. So, in 4 hours, we have done 50 problems. And here's all the work that we showed. It's pretty remarkable, actually. It's a lot of work. And I'm very proud of you. Here's where I messed up. Okay. Over here is where the audio was cut off. So I had to fix that. I'll fix it all with the little pin time codes. What a marathon. A lot of work. Okay, needless to say, if you're able to do all this, you're doing great. Okay, you're probably able to teach a class, really. If this was a struggle for you, just make sure to copy it all down, and understanding will come over time. So I'm not asking you to comprehend everything we just did. I'm asking you to practice it. Okay, It's like practicing a play. All right. So thank you very much, guys. I know this was a hit. This was a tough one, but we stayed in it together, and we made it through. So thank you guys very much. Make sure you go into Kuta and put these answers in. So we've got the data to back up your work, and staple, I think your work's all stapled together. Make sure you write all this down and bring it to class by Wednesday. Right, so the Kuta assignment is due at by 8 a.m. on Wednesday. The physical document is going to be turned in, or I'll check it on Wednesday when you get to class, and then you can use this document as notes for the test. So the way I'm going to do the test is I'll do somewhere between, I'm going to think about it, somewhere between 10, 15, 20, 25 problems on the test, and they'll just be picked at random from this problem set. Fact of the matter is, sometime on today, which is Saturday, you'll have the whole problem set on YouTube, and so you don't have to sit here and bite this or eat this elephant all in one chunk, but you need to go into you need to make some time here between Saturday and Wednesday. Okay, that's plenty of time to get through this 4 hours of video. And it doesn't have to be 4 hours for you. I mean, if you go through and solve a lot of these on your own, then that's less time to watch the video. But I'll stop it there, and I appreciate you all very, very much. Please make sure to like this video. It was a tough struggle for me as well. And subscribe to the channel if you aren't already. Hit that notification bell so you're always alerted to new videos on this channel. Thank you.